Machine learning, ML, is the scientific study of algorithms and statistical models that computer systems use in order to perform a specific task effectively without using explicit instructions, relying on patterns and inference instead. It is seen as a subset of artificial intelligence. Machine learning algorithms build a mathematical model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to perform the task. Machine learning algorithms are used in a wide variety of applications, such as email filtering, and computer vision, where it is infeasible to develop an algorithm of specific instructions for performing the task. Machine learning is closely related to computational statistics, which focuses on making predictions using computers. The study of mathematical optimization delivers methods, theory, and application domains to the field of machine learning. Data mining is a field of study within machine learning, and focuses on exploratory data analysis through unsupervised learning. In its application across business problems, machine learning is also referred to as predictive analytics. Machine learning tasks are classified into several broad categories. In supervised learning, the algorithm builds a mathematical model from a set of data that contains both the inputs and the desired outputs. For example, if the task were determining whether an image contained a certain object, the training data for a supervised learning algorithm would include images with and without that object, the input, and each image would have a label, the output, designating whether it contained the object. In special cases, the input may be only partially available, or restricted to special feedback clarification needed. Semi-supervised learning algorithms develop mathematical models from incomplete training data, where a portion of the sample input doesn't have labels. Classification algorithms and regression algorithms are types of supervised learning. Classification algorithms are used when the outputs are restricted to a limited set of values. For a classification algorithm that filters emails, the input would be an incoming email, and the output would be the name of the folder in which to file the email. For an algorithm that identifies spam emails, the output would be the prediction of either spam or not spam, represented by the Boolean values true and false. Regression algorithms are named for their continuous outputs, meaning they may have any value within a range. Examples of a continuous value are the temperature, length, or price of an object. In unsupervised learning, the algorithm builds a mathematical model from a set of data which contains only inputs and no desired output labels. Unsupervised learning algorithms are used to find structure in the data, like grouping or clustering of data points. Unsupervised learning can discover patterns in the data, and can group the inputs into categories, as in feature learning. Dimensionality reduction is the process of reducing the number of features, or inputs, in a set of data. Active learning algorithms access the desired outputs, training labels, for a limited set of inputs based on a budget, and optimize the choice of inputs for which it will acquire training labels. When used interactively, these can be presented to a human user for labeling. Reinforcement learning algorithms are given feedback in the form of positive or negative reinforcement in a dynamic environment, and are used in autonomous vehicles or in learning to play a game against a human opponent. Other specialized algorithms in machine learning include topic modeling, where the computer program is given a set of natural language documents and finds other documents that cover similar topics. Machine learning algorithms can be used to find the unobservable probability density function in density estimation problems. Meta-learning algorithms learn their own inductive bias based on previous experience. In developmental robotics, robot learning algorithms generate their own sequences of learning experiences, also known as a curriculum, to cumulatively acquire new skills through self-guided exploration and social interaction with humans. These robots use guidance mechanisms such as active learning, maturation, motor synergies, and imitation. Software suites containing a variety of machine learning algorithms include the following: free and open source software, CNTK, Deep Learning 4J, ELKI, H2O, Keras, Mahout, Mallet, Melpack, MXNet. New Octave. OpenNN. Orange. Scikit-learn. Shogun. Spark MLib. Apache System ML. TensorFlow. Root, TMVA with Root. Torch/PyTorch. Weka/Moa. Edureka. Proprietary software with free and open source editions. NEEM. RapidMiner. Proprietary software. Amazon Machine Learning. Angus Knowledge Studio. Azure Machine Learning. IST. IBM Data Science Experience. Google Prediction API. IBM SPSS Modeler. KXEN Modeler. Lion Solver. Mathematica. MATLAB. Microsoft Azure Machine Learning. Neural Designer. NeuroSolutions. Oracle Data Mining. Oracle AI Platform Cloud Service. Regression. SAS Enterprise Miner. Sequence L. Splunk. Statistica Data Miner. Applications. There are many applications for machine learning, including agriculture, anatomy, adaptive websites, effective computing, banking, bioinformatics, brain-machine interfaces, cheminformatics, computer networks, computer vision, credit card fraud detection, data quality, DNA sequence classification, economics, financial market analysis, general game playing, handwriting recognition, information retrieval, insurance, internet fraud detection, linguistics, machine learning control, machine perception, machine translation, marketing, medical diagnosis, natural language processing, natural language understanding, online advertising, optimization, recommender systems, robot locomotion, search engines, sentiment analysis, sequence mining, software engineering, speech recognition, structural health monitoring, syntactic pattern recognition, telecommunication, theorem proving, time series forecasting, user behavior analytics. Thanks for watch. Please subscribe, share, comment.